Hey guys, 125 here, watching launch of USSF-8 on a
159.
on an Atlas 55101.
Launch sequencer start.
Yeah, this is an
150.
unflown configuration,
Centaur LH2.
or as of yet
Securing
unflown.
Centaur LO2.
140.
Launch
So
enabled.
what this means is 5
137.
meter fairing, 1 solid rocket booster, 1 upper stage engine.
FTS arm.
T-minus 90 seconds. The launch vehicle, payload, ground systems, and eastern range are go for launch.
120.
With the use arm. FCS count started.
115.
Reduce ECS for launch.
Roger. 110. Bin valves locked. One minute.
T-minus 1 minute.
Range green.
Okay, so the range is good.
Seconds.
Stable at step 3.
Okay, well, what's that? T-minus 30.
28. 25.
Status check.
Go Atlas.
Go boost Centaur. Go USSF-8. ECDS
Minus
reduce for launch.
10, 9,
9,
8, 7, 6,
6,
5, 4, 3.
There goes the water tires. Ignition. SRB ignition and lift off the Atlas 55101.
United Launch Alliance Atlas 5 rocket carrying SF-8 for the United States Space Force.
Okay, that's a terrible count.
Now 10 seconds into flight. Vehicles begun the pitch over maneuver. Body responses look good.
You're now hearing the voice
Go.
of Patrick Moore providing launch vehicle ascent data.
Now 20 seconds in. RE-180 propellant utilization system has gone to closed loop control system. Response looks good. Now passing 30 seconds into flight. Vehicles completing the pitch over maneuver. Body rate responses continue to look good. Engine operating parameters continue to look good. SRB chamber
Basically,
pressure
everything's looking good.
within expected ranges.
So let's see, rock with
Now
a
coming up on
SRB.
58 seconds into flight. Mach 1, Atlas 5 is now supersonic.
Okay.
RE-180 engine operating parameters continue to look good. SRB
Into
chamber
the
pressure
clouds.
looks good. Now passing through max Q, maximum dynamic pressure. Body rates continue to look good throughout boost phase. Now 3 minutes remaining in the booster phase of flight. Now passing 1 minute 30 seconds into flight. SRB chamber pressure tailing off now as SRBs are burning out. And we have SRB burnout. RE-180 throttling down slightly as expected. Engine response looks
I
good.
think they're going to hold on to it just to let any excess thrust bleed off before from the SRB before they separate it.
Now passing 1 minute 50 seconds into flight. Body rates continue to look good throughout boost phase. RE-180 engine operating parameters continue to look good.
Look at and there it goes. It looks like there
Now
was
2
something
minutes
on
into
top
flight,
of that
we
SRB,
have
like
good
a little
indication of jettison of the
moisture of some
SRB.
kind, maybe.
The Atlas 5 now weighs 1/2 of its liftoff weight.
one hell of a
And
weight
vehicle's
loss
gone to
program.
closed loop steering. Body rates look good.
Closed loop means it knows where it needs to go and it will adjust its throttle and angle
2 minutes
to
remaining
get
in
it
the
there.
booster phase of flight. Atlas
This
5 is
mission
now
is fully
38
7
miles
hours
in
long.
altitude, 35 miles downrange distance, traveling at 4,200 miles per hour. Now 2 minutes 40 seconds into flight. RD-180 pump speeds and injector pressures continue to look good. Body rates continuing to look good throughout boost phase. Now passing 3 minutes into flight. And Centaur reaction control system is now pressurizing to flight levels. RD-180 now throttling down to maintain a constant 2.5 G acceleration limit. Engine response looks good as it's maintaining that 2.5 G acceleration limit.
Okay, so everything's going fine for the moment.
Now 1 minute remaining until BECO. And standing by for payload fairing jettison. And we have good indication of payload fairing jettison. And we have CFLR jettison. Now 3 minutes, 50 seconds into flight. Body rates continuing to look good. And RD-180 now throttling to maintain a constant 4.6 G acceleration limit. And we've begun boost phase chill down. And standing by for booster engine cutoff shortly. And we have BECO, booster engine cutoff, standing by for stage set. We have good indication of Atlas Centaur separation. We have pre-start on the RL-10. We have ignition and full thrust on the RL-10. Chamber pressure looks good. Body rates look good.
Yeah, this will be the only flight
will last approximately 8.5 minutes. Now passing 5 minutes into flight. Centaur's gone to closed loop steering. Body rates continue to look good. And the RCS system has begun initial thruster firings for thermal conditioning as expected.
Yeah, basically you just don't want to overheat any side of the vehicle.
Centaur is now 140 miles in altitude, 420 miles downrange distance, traveling at...
This is Atlas Mission Control at T plus 5 minutes and 25 seconds. We just heard flight commentator Patrick Moore confirm the successful completion of the early phase of today's flight, and all systems continue to operate nominally. Our next event, Centaur main engine cutoff, will occur in approximately 8 minutes. Earlier this week, Patrick Moore shared a little insight about his role as flight commentator and the vital information he relays to the launch team post-liftoff. Let's take a look.
Hi, my name is Patrick Moore. I'm a systems engineer in the Chief Engineer's Office at ULA, and I'm also your flight commentator for USSF-8. So my job as flight commentator is I'm taking a look at the screens here. I have some plots and schematics, and I'm also looking at the video on the wall. And so what I do is, as we're lifting off, I'm looking at the video, confirming that what I'm seeing on the screens are consistent. And then I'll start taking a look at the data in the plots and the schematics. And so my job as flight commentator is I'm looking at the data that I see here, and then I'm talking about it over the broadcast and on the net. And so the folks at ULA will be listening to my commentary, and so we have engineers that cover all different disciplines, avionics, structures, thermal, and many others. And so what they're doing when they hear my commentary is it just kind of helps give folks perspective of where we are in the launch and what's coming up. So an engineer will be looking at their specific system and all the different things that are going on with what's specific to their hardware in flight. And so my commentary helps tell them, okay, something's coming up that I might need to look at, or I should expect to see a change in my data in a certain way. And then obviously my commentary goes out to folks around the world watching the ULA broadcast. And so my job as flight commentator for them is to help provide some perspective of what they might be seeing on the broadcast and on the video to just help kind of pull everything together. So one thing that's interesting about flight commentary, when we have the rocket in flight, we're getting thousands of different measurements that we can select from, and they cover all different things from top to bottom of the rocket. So our job as flight commentators is we want to pick maybe 40 or 50 different measurements that give us an indication of how the vehicle is doing in general. We look at that in the plots here and in the schematics, and that really gives us more of a general feel that the rocket's doing well in flight, and then it's the job of the rest of the engineers throughout Denver that they're looking at much more specific measurements like a temperature on an avionics box or a pump speed in the engine or things like that. And so we may not look at those, but we want to look at maybe general indicators that tell us that the whole system is doing well. So I certainly get a little bit nervous before every launch. I've been doing this flight commentary for 4 years and about 12 launches, and I think I get nervous every time. I thought it would go away, but it doesn't. So I get really excited. There's a lot of adrenaline going, especially in the last couple of minutes before launch. And I think one of the challenges of being flight commentator is you have to, kind of live within that adrenaline, but also talk yourself down a little bit and stay focused on reading the data and talking over the net. And sometimes it's a little bit of a challenge, but it's always exciting. So for USSF-8, there's no difference in how I feel leading up to this launch. I'm really excited and can't wait.
Approximately 4 minutes now remaining in the burn.
Okay, this is just the first burn, because like I said, the mission will be about 7 hours long.
We are about 4 minutes away from MECO 1. While we wait, this year,
MECO, of course,
ULA's
may be cut
interim
off.
cryogenic propulsion stage will launch atop NASA's SLS rocket. ICPS will be carrying the Orion capsule to orbit. Let's hear the
basically
latest
down to
updates
4
on
per
this
stage.
program from ICPS avionics lead engineer Joven D. Herrera.
Hi, my name's Joven D. Herrera. I'm the avionics lead on ULA's Artemis program. Our whole team is excited to be part of America's journey back to the moon. ULA is working collaboratively with the Boeing company to supply the interim cryogenic propulsive stage, ICPS, for the Artemis 1, 2, and 3 missions. The ICPS is a modified Delta IV cryogenic second stage that is the second stage of the SLS rocket. This week, we are conducting program-specific engineering testing. This is a collaborative test with the whole SLS team to ensure all of the hardware powers on nominally and the vent and pressure systems respond appropriately. ULA is managing the ICPS power during this test. The Tiger team is a dedicated team on console that will support NASA's launch team. We work closely and collaboratively to monitor all aspects of ICPS during pre-launch and in-flight. We are so excited to be playing our role and returning back to the moon.
Yeah, how much longer until MECO at this point?
Now passing 11 minutes into flight, just over 2 minutes now remaining in the burn. Centaur systems all continue to perform nominally throughout the burn. Seeing good stable pressures on the RL-10. Body rates remain stable. Thruster activity continuing as expected.
Okay, that's just a live data taking a bit of time to load in. If you look at the perigee altitude,
This is Atlas Mission Control at T plus 11 minutes and 54 seconds. We are now approaching main engine cutoff 1. Let's listen in.
Passing 12 minutes into flight. Approximately 1 minute now remaining until MECO. Centaur is now 200 miles in altitude, 1,960 miles downrange distance, traveling at 16,350 miles per hour.
okay, we're doing good. Almost have an orbital insertion at this point.
.30 seconds now remaining until engine cutoff.
So that answers that question.
RL-10 operating parameters continue to look nominal. Body rates remain stable, now about 13 seconds until engine cutoff. PU's gone to open loop in preparation for MECO. Standing by for cutoff. And we have Miko.
There we go, we have Miko. Yeah, I'm
This is
line 5. That
Atlas
was launched
Mission
for
Control
USSF-8.
at
Goodbye.
T plus 13 minutes.